Hey, good morning. This is question 3 from the 2008 AP Calculus exam. Now, 2008, I actually think I misspoke in my previous video. 2008, you were actually allowed to use your calculator on questions 1, 2, and 3. So you had 45 minutes for 1, 2, and 3. Now, that has changed. And on the newer exams, you are only allowed to use your calculator on the first 2 questions, and you get 30 minutes. But this was a calculator active, so we'll, treat it as such. So it says oil is leaking from a pipeline on the surface of the lake and forms an oil slick whose volume increases at a constant rate. So we've got this 2,000, okay? The oil slick takes the form of a right circular cylinder with both its radius and height changing with the time. Okay, and they give us the volume. It says, at the instant when the radius is 100 and the height is 0.5 centimeters, the radius is increasing at a rate of 2.5 centimeters. At this instant, what is the rate of change of the height of the oil slick with respect to time in centimeters per minute? Okay, so the first thing I would probably do for this is kind of write down all the stuff that I know. So I know for part A, I have the change in volume over time. That equals 2,000, and that's cubic centimeters per minute. I also have that the change in radius over time is 2.5. Okay, and I have that R equals 100, H equals 0.5. And then they did give me the volume formula. So sometimes they give you the formula, sometimes they don't. I think sometimes it depends on how complicated the formula is. So the first thing I'd want to do here is take the derivative of this pretty classic rate of change problem here. So I'm going to go ahead and take the derivative. So you're going to get the change in volume over time equals, okay? Now here you have 2 variables that are multiplied together, so you're actually going to have to use product rule here. So it's the first, which will be this, right, times the derivative of the second. So the derivative of that is going to be dH dt. So it'll be, all right, first times derivative of the second, okay, plus the second, so that's going to be h, times the derivative of the first. So the derivative of this is going to be 2 pi r, but again, we took the respect to something that wasn't time, so I need to tack on that dr dt. So kind of looking at this, I need to scooch over a little bit. Okay, so taking a look at that now, my goal is going to be to kind of plug in some information that I have. So let's see, I know this. Oh, I always check just to make sure that everything is, positive or negative. So here everything was increasing, so everything's positive. But make sure if something was decreasing, that would have to be negative. That's not the case here. So I'm just going to plug in. So we've got 2,000. And then obviously you have your calculator for this. So you can go ahead and type everything into your calculator. The only thing that I shouldn't know here is the dHdt, which makes sense because that's what I'm trying to find, right? The change in the oil slick. And my height was 0.5. And here we got times 2 pi. My R value was 100. And the RDT was that 2.5. Okay? So go ahead and type that into your calculator. Okay, so you type that in. You're going to subtract this from either side, and then you'll have to divide by 10,000 pi. So after some calculator work, you should get the change in height over time was that 0.03, it was 86, so I'm going to say 3, oh, sorry, I'm going to call that a 9. So I'll round to 3 decimal places there. Okay, so that's what you get for your change in height over time, and I think that is all that part A asked you for. Now this one didn't say indicate units in your answer. This would be in centimeters per minute though. So the height is changing, the height is centimeters per minute. Make sure that you're rereading the questions just to make sure you're answering the full question, because sometimes they count the units and sometimes they don't, depending on the question. Okay, next up we have part B. So again, we have this oil leak, and now they're bringing in a recovery device that's going to suck up all the oil, I guess, and the oil is going to be removed using that formula at centimeters per minute, and T is the number of minutes it's working. So oil continues to leak at 2,000 centimeters per minute. Find the time when it's at its maximum. Okay, so what do we know? We know that maximum has to occur at a critical value, right? And critical values occur when the derivative equals 0. So now for part B, we're going to say that dV dt, the change in volume now is going to be represented differently because now we have this device that's coming to kind of clean up. So we still have that 2,000 coming in, but now we have to subtract however much the device is removing. So, you have the 2,000 minus, however much this device is sucking up, which is that R of T, okay? So we know that since the critical values occur when the derivative equals 0, I have to think about when will this equal 0. So I'll say critical values occur when derivative equals 0. So when does this thing equal 0? Well, this is going to be 0 when R of T is 2,000, right? When you pick up that 2,000, then you'll have, the change will be nothing because you'll have nothing left. So we'll have this equals 0 when that thing equals 2,000. So basically that's asking you to solve for when is this 2,000. So that's what I'm trying to do. I'm trying to figure out when does this thing equal 2,000. So I'm just recopying the equation there, and I'm just plugging in 2,000 for this R of T, right? So I'm plugging that in right there, and now you're just solving. So you can divide both sides by 400. So 2,000 divided by 400 is 50. So that equals square root of T. And now that's going to give me, oh, sorry, not 55. Sorry, lost a 0 there. So here I have 2,000 divided by 400 is 5. Now I need to get T by itself, so you need to square both sides. So square both sides and you get 25 equals T. What does this mean in words? This means that after the device is working for 25 minutes, after the device is working for 25 minutes, right, 25 minutes, the volume is at the max. Is at its maximum. And again, we got that because you need to know that maximums occur at critical values, and critical values occur when the derivative is 0. So I took this derivative and said, when would that derivative be 0? Well, this thing is going to equal 0 when R is 2,000. So if I know that R is 2,000, I can figure out what time that's going to occur. And for that, I think you should get your full credit for part B, and that means there's only part C left. So part C says, by the time the recovery device began removing oil, there was already 60,000 cubic meters leaked out. Right, but do not evaluate an expression involving the integral that gives the volume of the oil in the time found in part B. Okay. Now, remember, the tricky part about these is, not the tricky part, but the part that people forget is that you always need to make sure you're taking into account that initial value. So the initial value is going to be that 60,000. Plus, right, all the stuff that was there. So from 0 to 25 minutes, because we said that our T from part B was 25, and we need to integrate, that's 2000 minus RT minus that. And that is with respect to T. It said set up and don't evaluate, so we can leave it like that. So again, what does this say in words? This says that, because it says the volume of the oil at the time 25. So the volume at time 25 is going to be all this oil. We're adding all that up, plus it said that there was already 60,000. So that is the expression for the total of it. And with all that, there was only 3 parts, A, B, and C to that, so that should get you full credit for question 3. Now remember, question 3, this was a calculator active question. However, that's not always the case in subsequent exams. For a lot of the other exams you're going to be looking at that are older or newer than 2008, you're only allowed to use your calculator for 2 of the questions. So just keeping that in mind.